I'm going to reject the null hypothesis and be fine. Okay? Because that's what these significant tests are all about. But when could I reject the null hypothesis and be incorrect? Well, let's just figure out when we reject the null hypothesis. So I reject the null hypothesis when I get a sample mean really far away from that 100, or even further. Okay? So if I get the sample mean, whatever this number is, and we're going to calculate this number, or further, I get a p-value that's going to be less than 0.05. Or less than or equal to, it won't really matter. The equal to doesn't actually matter because we're a continuous distribution. Okay? So when do I get a p-value of less than 0.05? Well, I just need to figure out at what point on this normal distribution would give me a p-value of 0.05 or 0.04 or 0.03 or 0.02. So let's figure that out by getting a z, a critical z for that point. And for that, I'll do like an inverse norm of 0.95, and I get 1.64. Now to find out that critical actual mean and not just a z, I use my formula z equals my mean, my sample mean minus my hypothesized mean divided by my standard deviation divided by the square root of my sample size. And if you work that out, that comes out to be 104.4. Okay? So if I get a sample mean greater than 104.4, I'm going to reject the null hypothesis. So if I get 104.4 or 105 or 106, 107, anywhere out on that tail, going to put that in symbols now, 104.4, we reject the null hypothesis. Okay? What percent of the time do we reject the null hypothesis? 5% of the time. So, I don't have enough room. So, the probability of making my type 1 error is 5%. So 5% of the time, which is my alpha, which is my alpha for my 0.95. Did we ever say that we had an alpha of 0.05? That's one we usually use, so that's what I assumed. Okay. Alpha is always the probability of the type 1 error. Okay. So that's easy. That's really easy to control. Okay? Probability of the type 1 error is the easy error to control. Okay? So 5% of the time I'm going to reject this null hypothesis when 100 was actually true. Most of the time I'm going to reject the null hypothesis, and I do it, let's remember why we reject the null hypothesis. I got a mean so far away from this 100 that I don't think this was the true distribution. I don't think the distribution was really centered at 100 because I get this mean very rarely. Maybe my distribution was really centered someplace else. And mostly that's what that's going to mean. But 5% of the time, this distribution was the accurate distribution. The center was at 100, but I got one of those oddball samples. Okay? So usually we're fine with our rejection of our null hypothesis at those, at those means that far away. Okay. All right. Let's see if I can get another. Oh no, I'm fine. Here we go. All right. Type 2 error. Little harder. Got to have a little information that we generally won't have. So my probability of if I want to find the probability of a type 2 error, I have to test against some other unknown mean. So this mean, and I'm going to set another mean at 105. So let's say that our actual mean was 105. Our mu was 105 for our population. We're going to call this mu sub A. My probability of finding the type 2 error given an alternative population mean of now we'll try 105. Where do I get this 105? You're usually going to have it given to you. It usually comes from historical data and what you want to, how accurate you need your testing to be, and it's a little more complicated than and requires knowledge of the field that you're actually working in, not statistics, but the potato field you're actually working in. That would allow you to test against this 105. Okay, so we don't know that, so I just made a number up. Okay, so what if the real center was at 105? Now let's think back. Our original hypothesis was that my mean was at 100, and I would reject my null hypothesis if I got a mean greater than 104.4. So if the 105 was the true mean, let me put that 104.4 here. And think about this. I would reject my null hypothesis if I had a mean over this way. Don't shade. Because type 2 errors are about failing to reject the null hypothesis. So I'm not talking about a sample mean greater than 104.4. I'm going to fail to reject. I fail to reject when I have means less than 104.4. I don't reject my null hypothesis. So here is my fail to reject region way over here. Okay? So if I fail to reject, that's when I'm making the type 2 error, and I fail to reject against some other mean here of 105. So my probability of my type 2 error is going to be the probability that my sample mean is less than 104.5. Okay? So how do I find that? Well, let me get a z-score for 104. I'm sorry, 104.4, not 104.5. Sorry. You look at me like I'm crazy. I read the numbers wrong. Did this last period too. So let me get a z for 104.4 using this new hypothesized population mean, using my same standard deviation, my same sample size. I get a z of, I know I got it here somewhere, negative 0.22. So now I want to find the probability that I'm in this yellow area over here. So my z is less than negative 0.22. I do that with a normal CDF from negative infinity up to negative 0.25.